Greetings everyone, welcome to video number 27 in the project management series presented by Process Geekoid. Today's agenda will be going over reviewing the PMBOK process table as well as the 24th process, which is the plan quality management process. This process occurs at the intersection of the quality knowledge area and the planning process group. As always, please subscribe, like, and comment. So let's move forward. So we are now in the fourth part of planning, which is for quality. This explains how as a project team we will deliver a product, service, or result to meet the customer requirements or the voice of the customer. Now, plan quality management is the process of identifying quality requirements and standards for the project and its deliverables and documenting how project will demonstrate compliance with relevant quality requirements. So the quality requirements are going to vary based on what, as a project team, we are going to give the customer. This could be a cell phone, a piece of software, a car, or some form of product, service, or result for the customer. So quality requirements are going to be different for each kind of outcome that we plan to give for the end client. But regardless to say, plan quality management is the process that establishes policies, procedures, and documentation for planning, managing, and achieving project quality. So the ITTOs for plan quality management are shown here. For inputs, we have project management plan, which consists of the scope baseline, schedule baseline, cost baseline, and other management plans that contribute to overall project quality. Then you have stakeholder register, which is an output from identify stakeholders process as part of the initiation phase. Then you have risk register, which is an output from identify risks, which is part of risk planning. Then you have enterprise environmental factors, or EEFs, which are factors that are not in the control of the project team that influence, constrain, or direct a project. And this could come in the form of government agency regulations, such as in the car of automobile manufacturing, the National Institute of Highway Safety standards, to make sure that each car meets the minimum crash test ratings. Then you have industry standards, working operating conditions for a product to be accepted by the general public. So this could be OSHA standards. Industry standards could come in the form of, let's say, if you're making a washing machine, a product, you need to make sure you meet the Energy Star ratings. And then you have cultural perceptions, which influence expectations of quality. For example, in the Western countries, even in most countries, examples of expectations of quality and perceptions could be that, a Mercedes-Benz should have high quality versus a Chevy. So making sure that you meet this quality that is perceived by the customer is really important. Otherwise, the reputation of the company will be at stake. Examples of this would be where Volkswagen recently failed to live up to its expectations of quality due to the diesel emission standards scandal and lost a large customer base by cheating emission inspectors. So there is no way that you can cut through the government regulations as part of enterprise environmental factors. You must live by the rules. Then you have organizational process assets, which are standard organizational processes, policies, and procedures for meeting quality guidelines. And it also consists of historical lessons learned database with information tied to quality planning. Then you have tools, and for tools we have cost-benefit analysis. If the cost outweighs the benefits, then we do not do the project. And if the cost-benefit ratio is greater than 1, then we don't do the project because we are spending more than we are gaining for benefits. Then we have cost of quality, which comes under two flavors. A cost of quality equals cost of conformance plus cost of non-conformance. Obviously, we want to conform as much as we want to. So cost of non-conformance should be 0 in a perfect world, but it's not. So cost of conformance is where we have prevention cost and appraisal cost. Prevention costs consists of building a quality product, which consists of training, documenting processes, equipment, and time to do it right the first time. So these are examples of prevention costs. Next, we have appraisal costs, which is used to assess the quality, and this consists of testing, destructive testing loss, inspection costs. This all falls under cost of conformance, which is part of cost of quality. The next part of cost of quality is cost of nonconformance, which needs to be nullified as much as possible. This is internal failure costs, which is failures found by the project team, such as rework or scrap. Then you have external failure costs found by the customer, which you don't want to happen, which is liabilities, warranties, lost business. So cost of nonconformance is money spent during and after a project because of failures, whereas cost of conformance is money spent during project to avoid failures. Cost of conformance plus cost of nonconformance all fall under cost of quality. Then you have 7 basic quality tools, which consists of cause and effect diagram, and you can see the cause and effect diagram down here, where it is a fishbone diagram or Ishikawa diagram used to identify the root cause of a problem. Then you have a flow chart, which is often used during an audit process to find out root cause of a problem in the process itself and make sure you can identify risk and controls around a process in a flow chart, and also make sure that you can find gaps and best practices in the flow chart itself. Then you have check sheets or checklists, which assist in making sure you did not miss any steps in the overall process to achieve quality. Control charts also are useful because they assist in making sure that you are going to make sure that we create a product within the specifications or specification limits given by the customers, along with internal control limits, upper and lower control limits. Then you have Pareto diagrams, which determine the most frequent occurrences of a problem, which is a line in the diagram that shows the cumulative line of adding up to 80%. And if you see here, you would focus on the minimum number of causes that would cover 80% of the problem. So if you had 3 out of 4 of the root causes affecting 80% of the problems, you would focus on these and you would minimize the problems down the road. That is the essence of the Pareto diagram, manifesting the Pareto principle, which states that you will solve 80% of the problems by focusing on 20% of the problems. Then you would have histograms, which shows the most frequent occurrence of a problem as a normal distribution, central tendency, dispersion, but no variations are shown within a distribution. Then you have scatter diagrams, which basically have correlations, which explain changes in dependent variable y versus independent variable x. And it would show if you had a lot of correlation, you would see that in a perfect world, you would have a straight line, even distribution with an R coefficient of 1. But if you have too many clusters and too many outliers, that will show that you are not achieving quality. And then for a next tool and technique, you are going to have the benchmarking. Benchmarking is where you are comparing the current project outputs to a previous project that did achieve quality and making sure you achieve the benchmark. And if you did that, that means you have achieved quality. You're duplicating another successful project is basically what benchmarking is about. Then you have design of experiments, where the experiment is done to determine whether we can create a product by designing parameters. So an example would be a car manufacturing company such as Honda was asked to create a shock absorber and for a Honda Civic. And so the company will then have to run an experiment by changing various factors, setting up the line of cars by changing the right temperature and settings required for the shock absorber for the Honda Civic to work in. So the Civic will then be tested in these environment, various factors, and see which factors will result in higher satisfaction for the customer. That is the essence of design of experiments, where we are tweaking a factor to see how it impacts the overall quality of the product, service, or result. And basically the next tool or technique is Statistical sampling, where we're taking a sample of the population, and this is representative of the overall population at large. By doing so, we sample a bunch of, let's say, cars or phones and see if they achieve quality. If you see a large proportion of problems, then it would be a red flag for the team to stop producing phones or cars that have defects. This will prevent you from giving defects in the first place. Then you have brainstorming, which is basically taking unfiltered gathering of ideas to find better ways to achieve quality in the planning phase itself. Then you have force field analysis, where you want to have forces that support quality against forces that hinder quality. You want to outweigh the forces that hinder quality and have forces that achieve quality more. So that's what we're looking for. We need to have a good environment. So Toyota has inbuilt quality processes in its factories. That's why Toyota is known for high quality cars. For this very reason is they have it built within the Gemba during the car manufacturing process. Then you have nominal group technique, where you want to take all of the brainstorming ideas and prioritize these ideas for quality improvement in the quality plan, and you want to focus on ones that achieve high quality. Then you have additional quality management tools and meetings, which we'll deal with internally to make sure that we will meet quality for the overall customer. Outputs then are going to be quality management plan. Quality management plan is a subsidiary plan of the project management plan. And keep in mind that this plan is a process of identifying the quality requirements and standards for the project and deliverables, and documenting how the project will demonstrate compliance with the relevant quality requirements. Then you have process improvement plan, as we just mentioned. Using the 7 quality control tools, you can look at the processes in place and see if there are places to improve. Then you have quality metrics, quality checklists, and project document updates. Project document updates are usually done to the stakeholder register, responsibility assignment matrix, and WBS and WBS dictionary. Process improvement plan will have plan to improve the process boundaries, process configuration, process metrics, and targets for improved performance. Those are all part of process improvement plan. Also keep in mind that process improvement plan will be an overall subsidiary plan of the project management plan. So it will fall under the project management plan along with the quality management plan. So next, the key benefit of this process is that it provides guidance and direction on how quality will be managed and validated throughout the project. And we need to make sure we meet this quality for the customer. Next, we'll go over quality versus grade. Quality is where the degree is set of inherent characteristics to fulfill customer requirements. Grade is basically one step above that. Grade is where you are trying to assign a deliverable to having the same functional use but different technical characteristics. Classic example here is going to be a smartphone versus a cell phone versus a flip phone. So a smartphone versus a flip phone. Smartphone and flip phone should have no difference other than the functional characteristics and use, but they still achieve the same result, communicating from party A to party B by giving a phone call. And at the end of the day, you never want to sacrifice quality to achieve grade. You must achieve quality before you achieve grade. So just having a great iPhone does not mean you're achieving quality. You can have an iPhone that will not meet quality by heating up and catching on fire. So you don't want that happening. So quality is first, grade is secondary. So then you have precision, which is a measure of exactness, and then accuracy is an assessment of correctness. You want to be precise and accurate. As you can see here, you want to be in the right locality, but also you want to have a number of measurements that stay within the overall proximity of what you want to achieve. Then this slide shows the 7 basic quality tools. So again, cause and effect diagram shows the fishbone diagram, root cause. Then you have flow charts that shows defects or any issues in the process, checklists, control charts, Pareto diagrams that manifest the Pareto principle, histograms, and scatter diagrams. Thank you for watching. Please subscribe, like, and comment.